Now, good morning to all. We are in the second unit, that is 8051 microcontroller. In today's lecture, we are going to elaborate the concept of architecture of 8051 microcontroller. Okay. So before that, in 5 minutes, we will revise the basic thing. Okay, see here. What is the microcontroller? It is a small computing system which contains CPU, memories are two types: RAM, ROM, timer, counters, ADC, DAC, and IO ports on a single chip. Okay, so where we are going to use the microcontroller in different electronic units like cell phone, pager, watch, in your digital watch here, then calculators, video games, alarm clock, air conditioner, TV remote, okay, microwave oven, and washing machine. These are the simple and some basic example of microcontroller. So it is a block diagram of microcontroller. So if we compare microcontroller with microprocessor, what we can say about the microprocessor? It is a simple CPU. What you can say about the microcontroller? It is CPU along with all necessary peripheral devices mounted on single chip. Which are these necessary devices? These are nothing but the IO ports. What is the use of IO ports? To give the data or to take a data from the processor or from the CPU. Now see here, that is not the case available in the CPU. So to give the data and to take the data, there is not a single pin available in the CPU. So what we have means how we can give the data in microprocessor, we have to use another IC, that is 8255. So whenever we want to connect any peripheral devices to take the data or to give the means to take the data from the system to give the data to the system, we have to use a separate IC 8255. Actually that is not the part in your syllabus, but you again when you are going to means elaborate the microprocessor interfacing, then firstly you have to study that IC also. What is the use of that IC 8255? It is used, it is acts as a input and output pins, okay, to give the data to the microprocessor and to take the data. That is not the case with microcontroller. Why? Because for the microcontroller you are having inbuilt, and for that same IC you are having input and output pins. So with the help of that pins you can give the data, and with the help of the same pins you can take the data. Okay, so timer, counters to create the automation, RAM, ROM to save the data. Now next concept is embedded system. What is exactly the embedded system? It is a system which is used to design or which is used to create the automation. Okay, so it contains two part: microprocessor, hardware and software. And whatever the hardware part is there, it is nothing but your microcontroller. Next one we have seen, that is the characteristics, which is the very important part. So first and very most important characteristic about the ES is a single feature function or single featured. Once we design an embedded system for that particular application, we are not going to run any another application on that. Means embedded system designed for washing machine cannot use for the cannot use for the fridge, or embedded system, that is whatever the program you have designed, embedded system program you have designed for the fridge, you cannot apply that to the air conditioner. Okay, so whatever the for what application you are designing the system, that is limited to, means that system is limited to that application only. That's why it is called as a single function. Tightly constrained means what? You have to use all the space of the chip so that you can mount many devices and you can reduce the size. Okay, so that in terms you will get the fast operation. Reactive and real time, whatever the system you are going to design, it should be real time. Okay, whenever there is a changes in the environmental condition, it should be immediately implemented into the system. In this case we have seen the example of map. Okay, we are seeing the map on our mobile, and if we are moving on the road, okay, once as we are going to move, the same can be replicated in our mobile phone also, and that if it is means okay, then only you can say your system is good. Okay, now for example, you are at one point and you are planning to destination with another point. Once you reach at the destination, still if your mobile phone shows the distance is 3 kilometers, it is okay? Of course not. Okay, according to your movement, the distance should be reduced, and so once you get the destination, it should that zero, means zero distance remaining. Okay, that should be the real time. Means what? Whatever the exactly happening around ourselves or around the system, that should be immediately captured by the system, and that's why it is called as a reactive and the real time. Again, microprocessor base, every embedded system need a brain to create automation. Your brain is nothing but your CPU. which is either you can use directly microprocessor and connect the means connect the remaining peripheral devices externally, or you can use the microcontroller. Okay, in the microprocessor also, in the microcontroller also, you need a brain. And what is the, if we consider this diagram, what out of this, which system acts as a brain? Your CPU, that is central processing unit, that is the brain of the system. And because of the CPU, your means what, automation is possible. Then the memory, to save the data you need a memory connected. Now your system must be connected, so connected to the peripheral devices. Okay, you are design one system, but once you are integrated another system, okay, then your design means whatever is your project, it is not always contain the one system, it contains combination of many system. Okay, so your system should be connected that other devices can be accessed as a input and output, which is able to connect to your system. And last one is the software and hardware part. As the embedded system contains both the parts, software and hardware, so software part gives you the more flexibility, while hardware part gives you the security and the performance. Okay, so here is a difference between microprocessor and microcontroller. Microprocessor is the heart of computer system, microcontroller is the heart of embedded system. Okay, it is just a processor, means it contains only memory, IO ports have to be connected externally. There is no memory and nothing, IO input and output ports are available for the microprocessor. So how we can give the data, or how we can take the data? For that we need an additional IC, and when we combine these two IC, then only there is an input and output transfer is possible. That is not the case with microcontroller. You can easily give as input data, you can take a output data by using IO pins. Again, it is having all internal all peripheral devices internally. Since memory and IO has to be connected externally, the circuit becomes large. It is a quite complicated. It is on a single small chip, and which is tightly mounted, cannot be used in computer system, and hence inefficient. Sorry, in cannot be in a compact system. Why? Because you are connecting all the devices externally, and then how you can make the compact structure? Okay, so as it is already present inside, that's why it is a compact. Compact means what? Ki size lahan आहे त्याची. Okay, so cost of the entire system increases. Okay, you are means आता for example consider करा, if you want to connect for example speakers to your TV. Okay, so additionally you need a two to three circuits. Okay, whenever you want to connect microprocessor to the peripheral devices, you have to use the another IC8255, then and then only you can connect all these systems. So whenever you are going to connect externally something, you need additional circuit, and that's why your system cost is increases. Here the cost of the system is low as compared to microprocessor based system. Due to external components, the entire power consumption is high. Of course, there, as you are increasing the number of components, your power consumption is high, it should be less. Now see here, most of the microprocessor do not have power saving features. In microcontroller you are having power saving features. Okay, same will for same power saving you have a separate SFR, that is PCON. ओके, व्हॉट इज एक्झॅक्टली मीन बाय द पॉवर सेव्हिंग? नाव आता कन्सिडर करा की आपण मोबाईल यूज करतो. ओके, सो वेन वी आर गोइंग टू यूज अ मोबाईल, आपल्या ज्या काही बॅकलाईट्स असतात त्या ऑन असतात. ओके, ना आता कन्सिडर करा की तुम्ही म्हणजे आपलं कन्व्हेन्शनल लेक्चर आहे की तुम्ही क्लासरूम मध्ये बसलेला आहेत आणि आपण शिकवतो, आणि त्या केसमध्ये तुम्ही नॉट मोबाईल यूज करत नाहीयेत, मग त्या केसमध्ये तुमच्या लाईट वगैरे चालतात का? नाही, ते तिथे ऑफ असतात. ओके, जेव्हा तुम्ही परत तुमच्या टच पॅडला स्क्रीनला टच करता तेव्हा मग त्या बॅकलाईट चालू राहतात. मग याला काय म्हणायचं? पॉवर सेव्हिंग मोड म्हणायचं. म्हणजे जेवढ्या पॉसिबल ऍप्लिकेशन्स आहेत तिथं सगळीकडे, इव्हन पीसी मध्ये पण आपण बघतो की थोड्या वेळ जर पीसी आपण कीबोर्डला वगैरे हात नाही लावलं तर ते काय स्लीप मोड मध्ये जातो, परत मग तुम्हाला एंटर करावं लागतं, मग पुढची स्क्रीन ओपन होते. मग हे काय आहे? तर हे पॉवर सेव्हिंग मोड आहे. ओके, जेव्हा तुमचा मॉनिटर चालू असतो किंवा तुम्ही बॅकलाईट तुमच्या चालू असतात तिथे सुद्धा काय होते? तुमची पॉवर कन्झ्युम केली जाते. मग जेव्हा तुम्ही ऍप्लिकेशन रन करत नाहीयेत, आता फॉर एक्झाम्पल की तुम्ही एखाद्या वेगळ्या कामामध्ये आहात आणि तुम्ही म्हणजे मोबाईलला यूज नाही करत आहे, मग त्या केसमध्ये तो बॅकलाईट किंवा पूर्ण आपली स्क्रीन ऑफ असते, त्याला काय म्हणायचं? पॉवर सेव्हिंग मोड म्हणायचा. सो दॅट फॅसिलिटी इज नॉट with every microprocessor, but that facility is available in the microcontroller. Okay, now see, since memory and IO components are all external, each instruction will need external operation, hence it is relatively slower as compared to microcontroller. Microprocessor operations are slower. Now less number of register. Okay, see here, microprocessor have less number of register. Only 6 general purpose registers are available in microprocessor to operate. Which are these? That is B, C, D, E, H, L. Now you means आता तुम्हाला clear idea आली असेल की what is the use of the general purpose registers. Whenever you want to perform any operation, your data should be in the one register. Okay, so if you want to perform more operations, then you need a more registers. Okay, but that facility is not available in the microprocessor. Okay, that is available in the controller, because in the controller you are having 32 general purpose registers. Okay, in this case you are having only 6 general purpose register. What is mean by general purpose register? For any operation you can use that registers. Okay, in the microprocessor we have seen 6 general purpose register. Which are these? That is B, C, D, E, H, L. Okay, now like that in microcontroller you are having 32 general purpose registers are there. Okay, for example आता इथे मग फास्टचा काय विषय आहे. ओके, इथे आपण काय लिहिलंय बघा, ऑपरेशन्स. सी हिअर आता इथं तुमच्या स्पीडला पण जास्त अफेक्ट होणार, कसं ते सांगते. नाव कन्सिडर करा की तुम्हाला 7 नंबर स्टोअर करायचे. ओके, इफ यू आर हॅव्हिंग 6 नंबर्स ओनली, म्हणजे तुमच्याकडे तर मायक्रोप्रोसेसर मध्ये फक्त 6 नंबर स्टोअर करा, मीन्स 6 जनरल पर्पज रजिस्टर्स आहेत. मग तुम्ही काय करणार, आधी त्या 6 वर ऑपरेशन करणार, एक फ्री झाला की मग 7th रजिस्टर स्टोअर करून ऑपरेशन करणार. इथं मायक्रो कंट्रोलर मध्ये काय की तुम्हाला अवेलेबल करून देतानाच 32 केलेले आहेत, म्हणजे 7च्या 7 रजिस्टरवर तुम्ही एका वेळेस डेटावर एका वेळेस ऑपरेट करू शकता. ओके, and that's why microcontroller is operated very fastly as compared to microprocessor. Okay, so here you are having only 6 general purpose register. Here you are having in the microcontroller you are having nearly 32 general purpose registers. Now see here, only name are going to change. Okay, here you are having name as a B, C, D, H, L. Here you are having R0, R1, R2, R3, R4, R5, R6 and R7. Okay, so R0 to R7 you are having 32 general purpose registers. Now last, microprocessors are based on von Neumann model and microcontroller based on the hardware architecture, where program and data memory is separate, as we have already seen in the notes also. In the microcontroller, program and data memory is separate, so at a time you can access program memory and data memory. That is not case with the microprocessor. It is having same location program memory and data memory. Okay, so that's why microcontroller is fast and mainly used in a personal computer, mainly used in a specific application. Okay, and now see, this is ही फक्त डायग्राम बघून तुम्ही लगेच आयडेंटिफाय करू शकता. ओनली सीपीयू इज नथिंग बट युअर मायक्रोप्रोसेसर. So to operate or to perform any specific operation, you have to connect all these devices externally. Okay, now look towards the controller. It is a single chip. On that single chip you are having CPU, that is your microprocessor. Again you are having necessary devices, which are these IO devices, RAM, ROM and timer counter. Okay, and serial port. So because it is a compact structure which is give you all the facility on this single chip. Okay, once you buy this single chip, you will get all the necessary devices which is run to which is used to run some specific or basic operations. Now there is a facility, if you want to go for advanced operation, there is a facility to interface with these devices. So in this case, in the microprocessor, for performing basic operation also you have to go towards the interfacing. That is not the case with CPU. Okay, then here is a family of 8051 which we have already seen. Now just revise the features. What is the features? First thing is it is a 8-bit microcontroller. Why it is 8-bit? First reason, or the main reason, is ALU is 8-bit, and the secondary reason is all the internal databases and the registers are having the capacity of 8-bit. Now 4 KB ROM, 128 byte RAM. As we know that program and data memory is separate. So dual 8-bit timers, dual means 2. It is having 2 timers. Each timer is having capacity of 16-bit. Even same timer can be used as a counter. Then we have the separate chapter, or we have the separate unit for the timer and counter. So at this moment only remember that it is having 2 timers, and each timer is of the size 16-bit. Then it is having total 32 input output lines, and these 32 input output lines is divided into 4 ports. Each port is contains 8 lines. Okay, now it is having full feature serial port. Then it can address 64 kilobytes of program memory, and it can address 64 kilobytes of data memory. Now here maybe you confuse that here the size is different, and how we can access 64 kilobytes of memory. Accessing is depend upon the address lines. Okay, so it suppose it is having 16-bit address lines. Data means whatever the data bus is there, it is of 8-bit. like same as that of the microprocessor, and the address bus is of 16-bit. So with the help of 16-bit address line, you can access 64 kilobytes of memory. So it can access, but in this 8051, you are having the capacity of 128-byte RAM and 4 kilobytes of ROM. Okay, then it is having the means we can connect two external interrupts. It is having the facility to connect with two interrupts externally. Internally, it is supports 6 interrupts, and the clock frequency is 12 megahertz. Okay, so this is up to the revision, means up to the last lecture we have seen. Now very important part, that is the architecture of microcontroller. Okay, as we know that microcontroller is can be abbreviated, means in the can we write as a macros mu c. Okay, mu means micro, c means controller. Okay, so sometimes you can use word mu c or mu p, but I will suggest you that in the exam you have to write fully, that is microcontroller, microprocessor. Don't go for the short forms. Okay, so see here, this is the ALU. Actually here B is not there, actually A is there. So better way we will go for our diagram. Just wait. Okay, is it visible diagram? Hello, hello.
Yes, ma'am.
Okay, now see, this is the architecture diagram of 8051 microcontroller. Now in the exam, the question may ask like, draw the architecture of 8051 in detail and explain in detail. Now see here, sometimes they give that draw the architecture and explain any 4 blocks, or sometimes they ask like draw the architecture of 8051 and explain the working of PSU, working of ALU, like that. Okay, so you have to go for this. It is a very simple to explain, as I have already cleared that there is another diagram of the architecture which looks same like as that of the microprocessor. You can go with that, or you can go with this. This is very simple, and this is very, means why this is simple, because once you there is a two different diagram, you won't get confused. Okay, so see here, the main thing is the ALU. Okay, now you tell me, what is the long form of ALU? ALU stands for,
Arithmetic and logical unit.
very good. ALU stands for arithmetic and logic unit. Okay, it is used to perform arithmetic and logic operation. Okay, now you tell me, what is the size of ALU in 8051?
8-bit.
Very good. So only 3 to 4 sentence for the ALU. Okay, so how you can write, means while explaining the architecture, you can explain 3 to 4 lines for each block. Okay, now see here, ALU stands for arithmetic and logic unit. Okay, now it is used to perform it is used sorry, ALU stands for arithmetic and logic unit. Now it is used to perform arithmetic and logic operation. Now you tell me any 4 arithmetic operations.
Addition, subtraction, multiplication, division.
Okay, so arithmetic operations like addition, subtraction, multiplication, division, increment, decrement, etc. Okay, it also perform the logical operations like AND, OR, XOR. XNOR, NAND. Okay. Now only 4 sentence. Is it okay? Now कोण सांगते? Okay, Shraddha. Tell me 4 sentence about ALU.
ALU is 8-bit. It is used to perform arithmetic and logical operation when operation is performed by ALU. Result is stored in accumulator and the status of the result is stored in flash.
Okay. Now see here, ALU is a ALU. Okay, I will repeat once again. ALU stands for Arithmetic Logic Unit. Okay, it is 8-bit long. Second sentence. Now it is used to perform arithmetic operations like addition, subtraction, multiplication, and division. Okay, and logical operation like AND, OR, XOR, XNOR. Okay, after performing the operation, ALU store the result into the A register, and the status of result is replicated by the PSW. Now there in the microprocessor you are having flag register. Here the name is only going to change. It is called as a PSW, program status word. Okay, so only 5 sentence about ALU. ALU stands for Arithmetic Logic Unit. It is 8-bit long. It is used to perform arithmetic and logical operations like addition, subtraction, and or etc. And after performing the operations, arithmetic and logic operation, the ALU store result to the accumulator, and the status of result is stored into the PSW. Now is it okay with ALU? Everybody? Hello? Okay. Next, A register. Okay. PSW is the program status word. It is a flag register. Whatever the flag register we have seen in the microprocessor, now like that PSW is present in the microcontroller. Okay, so as I have already many time I have told you that basic structure is the same, only something is going to change. Okay, so in the microprocessor you are having flag register, and in the microcontroller you are having PSW. Okay, so some of the flags are same, some of the flags is going to change. Now see here, A register, A stands for accumulator. It is 8-bit long. Okay, it is very important register. It is used means it is used in any arithmetic and logic operation. In any arithmetic and logic operation, first operand should be always present in accumulator. Okay, after performing the operation, the result is again stored into the A register. Okay, that's it. परत एकदा बघा, only 5 sentence about A register. How you can write about A register? A stands for accumulator. It is 8-bit long. It is used to means directly you can write that what this register in any operation, this register contains first operand. Okay, first operand by first operand. Now see, if you want to perform 5 plus 3, you can say 5 or 3 as well. Means you can say 5 into accumulator or you can say 3 into accumulator. But if you want to perform 5 minus 3, then your 5 should be in the A register. Okay, so that's why you have to use the word first data. So how you can write? A stands for accumulator. It is 8-bit long. In any arithmetic and logic operation, first operand is stored or is present in the accumulator, and fourth sentence is after performing any logical and arithmetic operation, the result is stored into the accumulator. Now who tell me about this 4 sentence about ALU? Anyone? Neha? Pooja? Chaitanya? What you can say about ALU? Only 4 sentence. A stands for accumulator. Second sentence, it is 8-bit long. Okay, what is the use of accumulator? In any operation, first operand should be present in accumulator. And last sentence ka hai? After performing any operation, the result is stored back into the accumulator. Now who tell me this 4 sentence? Chaitanya, Vishal, Deepak. No one? Okay. Who got the concept they can
I
tell? हाँ श्रद्धा.
A stand A stands for accumulator. Accumulator is 8-bit long. During arithmetic and logic operation, one operand is given by accumulator. When operation is performed by ALU, the result is stored in accumulator.
Very good. Okay, very good. Okay, exactly. Now next B register. B stands for B register. Now it is not a general purpose like a microprocessor. The B register present in microprocessor, you can use that register for any operation. But in this case, B register is always, or it is only used for multiplication and division operation. Okay. Now, whenever you are going to perform multiplication and division operation, in that case, only you have to go towards the B register. Otherwise, you cannot use B register for anything else. Now, see what you can say about the B register. B register, B stands for B register. It is 8-bit long. It is used in multiplication and division operation. Okay. If division is performed, okay, the division झाली. Now, if I told you that perform 5 divided by 3, then your 5 should be in A register. That is the first operand should be in A register. Your 3 should be in the B register. Okay. So after dividing 5 by 3, your answer is 1. So it is in the accumulator, but your remainder is in this case 2. So in the division operation, whatever the remainder is there, it is in the B register. Okay. So what you can say 3 sentence about B register. B register is 8-bit long. It is used in division and multiplication operation. And in the division, B register can carry. B register store the value of carry. Okay. Or the remainder, not carry, it is a reminder. So that is the 3 sentence about B register. Now who is going to tell? Vaishnavi, Pooja, Vedant. Fast. Only 3 sentence about B register. Shantanu, Saurabh. What you can say about the B register? 3 sentence.
B register is 8-bit long. It is used to perform multiplication and division operations. And when division is performed by B register, okay, when
Reminder is in the.
division, reminder is in the B register.
Very good. I think so only Shraddha is attentive to the lecture. What about others? No one has to reply. Why? Why Saurabh? Vishal? Is there any network issue with all? Not in the chat box also you are giving reply, not in by making unmute. समजत नाही आहे का? हॅलो काय प्रॉब्लेम आहे? हॅलो. ओके वी आर लिसनिंग मॅडम. Okay, पण जेव्हा when I am asking at that time only you can say na. Okay, repeat. I will repeat once again. Okay, I will repeat from the start. ALU. Now, ALU stands for Arithmetic and Logic Unit. It is 8-bit long. It is used to perform arithmetic and logical operations. Now, for sentence, it performs arithmetic operations like addition, subtraction, multiplication, okay, etc. It performs logical operations like AND or XOR, XNOR. After performing the operation, ALU store the result into a register and status of result into the PSW. Okay, that's it. Next, A register. A stands for accumulator. It is 8-bit long. It contains first operand during any arithmetic and logic operation. Okay. Now it also stores the result of operation. That's it. B. B stands for B register. It is 8-bit long. It is only used in multiplication and division operation. Okay. Now while performing division operation, B result is or the quotient ला आपण भागाकार म्हणतो. So result किंवा result म्हणा तुम्ही, result is stored into A register and the remainder is stored into the B register. So only 4 sentence about B. What is that? B stands for B register. It is 8-bit long. It is only used for in multiplication and division operation, and in the division operation B result is stored into A and the remainder is stored into the B register. Now who is going to tell? Okay, only 1 minute.
Reminder is stored into B register.
Okay, very good. Okay, now next one is your PSW. Now we for time being we just keep the PSW. It is a very vast concept, so just go for the PC. Okay, so PC stands for program counter. It is 16-bit long. It is used to point or it is used to access internal memory. Okay, once again I will repeat. PC stands for program counter. It is 16-bit long, same as that of the microprocessor. तिथे पण PC 16-bitच होता. And this, what is the use of PC? To access the internal memory. As we know that PC is a pointer which is just used to access the memory. Okay, next. So what is the 3 sentence about the PC? PC stands for program counter. It is a 16-bit long. It is used to access the internal memory. Now who is going to tell?
PC stands for program counter. It is 16-bit long and it contains internal
It is
data
used to
memory.
access internal memory. Okay, now we
It
shall
is
repeat once again this one. Vishal 43. थ्री सेंटेन्स अबाउट द पीसी मराठीतून सांगा. ठीक आहे, चालेल. फक्त तुम्हाला कळालंय का नाही मला बघायचंय. पीसी स्टँड्स फॉर विशाल. स्वप्नाली. पीसी स्टँड्स फॉर
program counter.
Okay. What is the size of program counter? How many bit long?
8-bit.
8 bit or 16 bit? Okay, 16 bit. Okay. PC is 16 bit long. And what is the use of PC? To access internal memory. What is the use? What its use? Repeat.
To access
Very good. To access the internal memory. Now next, Dptr. Dptr stands for D for data, PTR for pointer. So Dptr stands for data pointer. Okay, it is again 16-bit long. So PC is also 16-bit, Dptr is also 16-bit. Now see, Dptr is not a single register like PC. It is the combination of DPH, that is data pointer high, plus DPL. Data pointer high is 8-bit long, DPL is 8-bit long. Combinedly, it makes 16-bit and the name is Dptr. So Dptr stands for data pointer. It is a 16-bit long. It is the combination of DPH and DPL. Each DPH and DPL is 8-bit long. Now what is the use of Dptr? Dptr is used to access external memory. Okay, whatever the internal memory is there, it is accessed by using PC. Whatever the external memory, if we are interfacing external memory, okay. Now see here, sometimes, for example, internal memory is having less capacity. We are connecting the hard drive, hard disk externally. Okay, that is kind of external memory. So to access such type of the external memory, we have to use Dptr as a data pointer. Is it okay? So how you can write about data pointer? Dptr stands for data pointer. It is a 16-bit long. It is the combination of DPH and DPL. Each DPH and DPL is 8-bit long. And what is its use? It is used to access external memory. Is it okay? Is it okay?
Yes.
Okay. Now next ROM. ROM stands for read only memory. It is used for storing the data. Now in the feature only we have mentioned about the ROM. What is the size of ROM? 4 kilobytes. Okay. Now see here SFR. Now see, these are the SFRs. Okay, you are having many SFRs. Here we have listed some of the SFRs. SFR stands for special function registers. Now special function registers means what? These are the control units. Okay. Now which are these SFR? IP, that is interrupt priority, IE, that is interrupt enable, PCON, that is power control, SBUF, that is serial buffer, SCON, that is serial control, TCON, that is timer control, TMOD, that is timer mod, TL, timer low 0, timer high 0, timer low 1, timer high 1. These are the sum of the SFR. You are having separate point on the SFR, which is very important part. Okay. So if SFR stands for special function register, it is used to control the specific functions.